You see it on social media, screenshots from backyard telescopes, long bright streaks across star fields, everyone talking about how the tail got longer after the comet disappeared behind the sun. Some say it doubled, others claim it tripled. A few voices say alien engines. Most just wonder what changed. The interstellar visitor, 3, I-Atlas, emerged from solar conjunction in early November 2025, with what looked like a dramatically extended ion tail. But here's what nobody tells you. The tail did not suddenly grow. You did. Your angle changed. The geometry shifted. What was hidden became visible. What pointed away now points sideways. This is not magic. This is perspective. On July 1st, 2025, the Atlas Survey Telescope at Rio Hurtado, Chile, spotted something moving at 61 kilometers per second. Observatory code W68, apparent magnitude 18, 3.5 astronomical units from Earth, 4.51 from the Sun, border of Serpens Cauda and Sagittarius near the galactic plane. Within days, pre-discovery images surfaced from Zwicky Transient Facility going back to June 14th. More from Atlas itself, stretching to June 5th. Amateur astronomer Sam Dean found them. The trajectory was hyperbolic, eccentricity 1.000016. The third confirmed interstellar object. 3, I-Atlas. The I means interstellar. The 3 means third. After 1, I-Oumuamua in 2017, and 2, I-Borisov in 2019, this thing arrived from outside a carrying velocity 44 kilometers per second, faster than both predecessors, and a mass around 10 to the 15th kilograms, based on minimum 5-kilometer diameter from photometry. On July 2nd, observers at Deep Random Survey Chile, Lowell Discovery Telescope Arizona, and Canada France-Hawaii Telescope Mauna Kea all reported a marginal coma with potential tail-like elongation 3 arcseconds long. That same day, David Jewett and Jane Liu used the Nordic Optical Telescope and confirmed the object was clearly active with a diffuse appearance. Minor Planet Center announced it, gave it the interstellar designation, gave it the non-periodic comet label C/2025 N1. By announcement time, 122 observations from 31 observatories. Hubble Space Telescope captured it. July 21st, 2025, when the comet set 277 million miles from Earth. The image showed a teardrop-shaped cocoon of dust coming off the solid, icy nucleus. Because Hubble tracked the comet moving along its hyperbolic path, the stationary background stars streaked in the exposure. Those Hubble images from July 1st showed 3. I-Atlas had a very faint, broad tail pointing eastward away from the Sun. Standard cometary feature, small dust particles blown by solar radiation pressure. The broad appearance suggested high ejection speeds from the surface. But here's the critical detail buried in the technical reports. The anti-solar tail of 3 I-Atlas was thought to be pointed directly away from Earth in July 2025, directly away. That made it foreshortened, mostly hidden behind the coma. You were looking straight down the barrel of the tail, maximum compression. A 1,000,000-kilometer tail compressed into a few thousand kilometers of apparent length. If you value documented astrophysics and orbital mechanics like this, subscribe. It is the best way to support our work. Also comment from which city you are hearing this from. Also, this script is researched and factual using sources from Wikipedia's 3 I-Atlas article, updated November 17th, 2025, 7 hours ago. NASA Science's official Comet 3 I-Atlas. Facts page from July 3rd, 2025. The European Space Agency's ExoMars and Mars Express Observation Report. Peer-reviewed preprints from David Jewett and Jane Liu posted to Archive. Avi Loeb's Medium posts from October through November 2025, documenting 12 anomalies with timestamps. BBC Sky at Night Magazine's Virtual Telescope Project. Coverage from November 11th, 2025. Space.com's multi-part coverage tracking the comet from discovery through post-perihelion with journalist Chi-Cheng Zhang's quotes from November 7th, and technical data from JPL Small Body Database and Minor Planet Center orbital elements updated through November 4th. Now back to the information. By late August 2025, observations by the 8.2-meter Gemini South Telescope showed the anti-solar tail had become more visible, grown to 30 arcseconds in angular length, roughly 56,000 kilometers. Not because material suddenly appeared, but because viewing geometry evolved. The comet kept moving, Earth kept moving. The angle between your eye and the tail shifted from 0 degrees towards something approaching 90. Foreshortening decreased. The tail you could not see in July became the tail you could measure in August. James Clerk. Maxwell Telescope observed September 7th, 2025, when 3 Iatlas sat 2.33 astronomical units from the Sun. Hydrogen cyanide production, rate 1.5 plus or minus 0.5 times 10 to the 25th molecules per second. 1 week later, September 14th, that rate climbed to 4.5 plus or minus 1.9 times 10 to the 25th molecules per second. 2 kilograms per second. The cyanide coma on September 15th measured 180,000 kilometers across asymmetric, elongated along the anti-solar direction. Visible dust tail, 50 arcseconds across, corresponding to about 100,000 kilometers. Apparent magnitude, 14.2. Activity increasing as the comet closed on perihelion, but tail visibility increasing faster because of changing perspective, not just changing output. The comet approached perihelion October 29, 2025, at 1.36 astronomical units, 203 million kilometers, 126 million miles, between the orbits of Earth and Mars. But 8 days before perihelion on October 21st, it reached solar conjunction, on the opposite side of the Sun from Earth. For observers on this planet, the comet vanished. Solar elongation dropped below 30 degrees starting October 1st, stayed below through November 9th. Coronagraph rejection angles overwhelmed by scattered sunlight. Ground-based optical observations, impossible. The comet passed through the peak heating phase of its trajectory completely hidden from terrestrial view. During that window, solar radiation pressure maximized, sublimation rates spiked, ion tail formation accelerated, dust ejection intensified, all invisible to us because the Sun sat in the way. October 3rd, the comet passed within 30 million kilometers of Mars. ESA's ExoMars Trace Gas Orbiter and Mars Express turned their cameras toward it. Cassis on ExoMars TGO captured a series of images. The comet was a slightly fuzzy white dot moving downward near center. Coma, measuring a few thousand kilometers, clearly visible, created as solar heat and radiation brought the comet to life, causing gas and dust release. The comet was around 50,000 times fainter than what the orbiter normally views, imaged using 5-second exposures. Full coma size could not be measured because brightness decreased quickly with distance from nucleus, fading into image noise. Tail much dimmer than coma, not visible in Cassis images, but might become visible in future observations as heating continued. Mars orbiters tried spectral measurements, Omega and SPICAM spectrometers on Mars. Express Nomad spectrometer on ExoMars TGO. At that distance, uncertain whether coma and tail were bright enough for spectral characterization, scientists kept analyzing over weeks and months trying to determine composition and behavior as the comet approached the Sun. Colin Wilson, ESA project scientist, said, though, Mars orbiters continue making impressive contributions to Mars science. It is always extra exciting seeing them respond to unexpected situations like this one. Meanwhile, from 18 to 24 October, GOES-19 weather satellite observed the comet down to magnitude 12 as it crept closer to solar conjunction and perihelion. Then silence, the critical window. October 21st. Conjunction, October 29th. Perihelion. Velocity peaked, temperature maximized, outgassing exploded, the tail grew. Nobody watching from Earth. When you stand between a light source and a long object, the object casts a shadow behind itself away from the light. That shadow stretches in one direction. If you walk around to the other side of the light, the shadow now points toward you. The object did not change. The shadow did not relocate. Your position changed. Perspective shifted. What was hidden became visible. Comet tails always point away from the Sun. Ion tail made of charged particles blown by solar wind points almost exactly anti-solar. Dust tail curves slightly trailing the orbital path because larger particles retain more momentum. Before perihelion, as the comet approached the Sun from interstellar space, moving inbound, the tail stretched behind it away from the Sun. From Earth's perspective, in July, August, September, we saw the comet approaching with its tail foreshortened because our line of sight aligned closely with the tail direction. Think of looking at a broomstick head-on versus sideways. Head-on, it looks like a circle. Sideways, it looks like a stick. Same object, different view. During conjunction, when the comet sat on the opposite side of the Sun, the tail pointed almost directly at Earth. Maximum foreshortening. If you could see through solar glare, you would see a compact bright coma with very little tail extension, because the entire tail compressed along your line of sight into a thick, short spike. But after perihelion, after the comet rounded the Sun and began its outbound journey, the geometry flipped. Now the comet moved away from the Sun, with its tail still pointing anti-solar, which means the tail pointed in the same general direction as the comet's motion outbound. From Earth's position in November, our line of sight crossed the tail more perpendicular, 90-degree viewing angle. Minimum foreshortening, maximum tail visibility. Gianluca Massi, Virtual Telescope Project. Manciano, Italy, captured early post-perihelion images, November 10th, 2025, 0428 UTC. Comet, 12 degrees above eastern horizon, bright moon about 85 degrees from it. Clearly detected ion tail thanks to evolving geometry. He wrote now that the comet is moving into the morning sky. Its tail, which was behind the nucleus as seen from Earth at perihelion, is more and more visible. Next morning, November 11th, 0431 UTC, he captured it again, noting the ion tail getting longer as heat from the sun causes ices to sublimate into gas, venting into space. Not longer because more material appeared, longer because the angle changed. What was compressed became extended. What pointed at you now points across your field of view. The tail itself may have continued growing from increased sublimation post-perihelion, but the dramatic visible change came from geometry, not from a sudden doubling of output. David Jewett and Jane Lou Nordic Optical Telescope. November 11th, 2025. Primary mirror, 2.56 meters. La Palma, Canary Islands. Images showed single body, no evidence for breakup following perihelion passage 2 weeks earlier. Linear stretch contoured color, contoured spatially filtered within 0.13 million kilometer radius region by subtracting median signal and concentric annuli centered on brightest pixel. Prominent elongation in the glow surrounding 3I Atlas projected to position angle 106, plus or minus 10 degrees, close to projected sunward direction 115 degrees. Resembled Hubble image from July 21st, showing sunward anti-tail feature. Still present post-perihelion, that anti-tail itself is perspective effect. Larger dust particles less affected by solar wind linger in Comet's orbital plane. When Earth crosses that plane or views it, edge-on dust stacks across line of sight, creating spike pointing sunward opposite main tail. Not defying physics, geometry. The same way, stars stack across galactic disk distance creating Milky Way band. Comet, dust stacks across orbital plane creating anti-tail spike. Phase angle matters. Sun-comet observer angle. 0 degrees means looking straight down tail, maximum foreshortening, head closest. 90 degrees means line of sight perpendicular to sun-comet line viewing tail with no foreshortening. 180 degrees means looking straight down tail, again maximum foreshortening, but tail closer and head farther. Comet closer to sun than observer can achieve 90 degree phase angle at greatest elongation. Before perihelion. As 3I Atlas approached, phase angle stayed small. Tail pointed mostly away from Earth. After perihelion, as comet receded and Earth orbited, phase angle increased. Tail swung into broadside view. November, images resolved cleaner tail structure. Ion tail blue-green because ionized gases scatter sunlight differently than dust direction set by solar wind, not by comet motion. Chi-Cheng Zhang, November 7, 2025, stated, "We do not have any evidence for gas coma, changing colors. Our result just showed gas coma likely still around, contributing substantially to overall brightness. Color came from chemistry, not from alien tech. Hydroxyl OH produced when sunlight breaks up water. Classic outgassing. Meerkat Radio Array South Africa detected it. Textbook comet behavior. Some voices online claim the tail tripled in length after conjunction." They compare July images showing minimal tail extension to November. Images showing long ion streaks and declare sudden growth. They miss the geometry. In July, the tail pointed at Earth, compressed. In November, it pointed across Earth's view, extended. If the physical tail length stayed exactly the same, the apparent length would still increase by a factor of 5 or 10 just from perspective change. Actual sublimation did increase near perihelion, so real growth happened, but the visual drama comes from viewing angle, not from magic. NASA assets, gathered observations, Hubble, Webb, TESS, Swift, Sphere-X, Perseverance, Mars, Rover, Mars, Reconnaissance, Orbiter, Curiosity Rover, Europa, Clipper, Lucy Psyche, Parker, Solar Probe, Punch, Soho Juice. November 4th, 2025, ESA's Jupiter Icy Moons Explorer Juice passed within 64 million kilometers of 3I Atlas. Instruments included Janus Visible Imager, MAGES Infrared Spectrometer, SWI Submillimeter Wave Instrument. Comet farther from JUICE than from Mars. Orbiter's week earlier, but JUICE saw it just after perihelion, a more active state. Data rate very low due to JUICE position relative to Earth. Results expected February 2026. JUICE will observe again November 25th. March 16th, 2026. The comet passes within 54 million kilometers of Jupiter observable to UV infrared radio sensors on Juno spacecraft. December 19th, 2025. Closest approach to Earth, 269 million kilometers, 167 million miles. Still far, no threat. Hyperbolic one-time pass. Avi Loeb, Harvard astrophysicist, Galileo project head, has documented 12 anomalies about 3 I-Atlas since discovery. Trajectory aligned within 5 degrees of ecliptic plane likelihood, 0.2%. Sunward jet, anti-tail, not optical illusion from perspective. Unlike familiar comets. Nucleus, about a million times more massive than 1, Oumuamua, 1,000 times more massive than 2. Ibersov, moving faster, likelihood less than 0.1%. Arrival time fine-tuned to bring it within tens of millions kilometers from Mars, Venus, Jupiter, unobservable from Earth, at perihelion. Extreme negative polarization unprecedented for all known comets. Arrived from direction coincident with WOW signal within 9 degrees. Anomalies earned Loeb scale rank 4. Post-perihelion, he noted series of collimated jets extending million kilometers towards Sun, 3 million kilometers away. November 14th, 2025, medium post. He suggested technological thrusters. Pointing exhaust towards Sun would accelerate away from Sun. Mainstream view remains natural comet under solar heating and solar wind. Measurements ongoing. The jets he describes fit outgassing from rotating nucleus with active spots. Material ejected from sunlit side travels outward. At thermal speed, 400 meters per second, typical for sublimated volatiles, million kilometers takes about a month to traverse. Rotation period, 16.16 hours, measured July-August 2025. If jets stayed collimated, not smeared by rotation, that suggests either very directed venting from localized sources or observation timing, catching specific rotation phases. November 5th, 2025, 2 new images released. Our Naves Observatory Spain, virtual telescope project, showed compact source without clear cometary tail. Surprising, given non-gravitational acceleration detected by JPL and Minor Planet Center. Reports indicated comet lost at least 13% mass during perihelion passage, based on momentum conservation and rocket effect. Typical comet losing that much mass should show massive coma with dust and gas pushed by radiation pressure and solar wind, forming obvious tail pointing away from Sun. Images did not show it. Avi Loeb compared to Comet Lemon from Solar System taken November 3rd, 2025. Same observatory clear cometary tail away from Sun as expected. 3. I-Atlas compact, but by November 9th, 10th, 11th, images from Virtual Telescope and Nordic Optical showed tail becoming visible. Not because tail suddenly formed, because viewing geometry improved. Comet moved farther from Sun into morning sky. Angle between Earth and tail increased. Foreshortening decreased. Material that existed compressed along line of sight now spread across field of view, appearing longer. Pre-perihelion observations. July through September showed coma evolution. Initially, compact reddish dust dominated. As comet approached, Sun activity increased. Carbon dioxide, rich per JWST, near-infrared spectrograph. Small amount water, ice water vapor, carbon monoxide, carbonyl sulfide. Very large telescope showed cyanide gas, atomic nickel vapor concentrations, similar to solar system comets. Unusual composition, carbon dioxide dominated unlike water-rich solar system comets, but within range of interstellar possibilities. Comet possibly 7 billion years old, older than solar system itself if originated from Milky Way, thick disk, spent eons at interstellar temperatures below 10 Kelvin, possibly billions of years. First close approach to any star in that time. Volatiles frozen solid entire journey. Solar heat woke it. Sublimation began. Tail formed. All natural. All physics. Perspective made it look like the tail exploded in size after conjunction, when really the tail just rotated into view. Comparison helps. Comet. C 2022, E3, ZTF Green Comet early, 2023. Displayed foreshortened, fan-shaped dust tail late fall, early winter as it passed high above solar system plane. Later grew long corkscrew ion tail. January 23rd. 2023, Earth passed through comet's orbital plane. Dust shed previous months stacked across line of sight, creating anti-tail. Appeared ahead of comet sunward direction opposite dust tail. Seemed to defy logic, not defying anything. Larger dust particles less affected by radiation pressure lingered in orbital path. Earth crossed that plane dust stacked forming spike. Same mechanics apply to 3I Atlas. Comet C 2023, A3 Tsuchinshan. Atlas, October 2024, became naked eye visible. Long exposure images showed faint downward anti-tail sunward direction. Perspective effect. When Earth viewing geometry aligned with dust sheet left in orbit, larger particles lit by sun from behind, visible as spike. main tail bright particles blown away, anti-tail faint particles left behind. Both real, both explained by position and light. Comet C2024 S1 Atlas, different object, discovered September 27th, 2024, Atlas HKO Hawaii. Kreutz Sungrazer Perihelion. October 28th, 2024, distance 0.008. Astronomical units, 1.2 million kilometers from Solar System Barycenter. Population 2, subgroup, same family as Great Comet, 1882, Enikia Seki. Predicted to brighten magnitude -5 to -7 brighter than Venus if survived perihelion. Did not survive. Fragmented before perihelion, October 8th, found to be elongated, lacking central condensation overall, fainter, possibly disintegrated. Later observations. October 15th onward showed well-condensed nucleus, 2 magnitude outburst. October 15th, 16th, October 19th, coma, triangular, 2.4 arc minutes, tail 24 arc minutes. October 20th, magnitude 8.2. October 21st, faded to 10, another outburst. October 23rd, coma 1 arc minute, magnitude 10.8, tail 17 arc minutes. October 26th, Han Jietan PhD student Guangzhou discovered fragment ahead in LASCO images. Hours before perihelion comet evaporated, within 2 hours visible in SOHO LASCO C2 around October 28th, 0700 UTC. Disintegrated. Rotational instability, sublimation loss. Never made it. Different comet, different outcome. Shows not all comets survive perihelion. 3. Atlas did, stayed intact, kept moving. 3 types of perspective in art, 1 point, 2 point, 3 point, all rely on foreshortening. Objects appear shorter, compressed along axis parallel to viewer's line of sight. Degree of compression depends on angle and distance, affects perceived proportions and shape. Circle becomes ellipse, cylinder becomes wedge. Foreshortening creates depth on flat surface. Objects closer appear larger, farther appear smaller compressed. Key element in accurate perspective drawings. Lines that are parallel in reality appear to converge at vanishing point when viewed at angle. Building height nearer looks taller than distant side. Length along perspective appears smaller. Round top of cup appears elliptical at angle. Comet tail million kilometers long appears as short spike when viewed head-on. Same tail appears as long streak when viewed broadside. No change in tail, change in U. Artists know this. Break complex surfaces into simpler shapes. Cylindrical arms, elliptical cups. Capture geometry as it appears using projection techniques. Viewers. Brains trained from birth to reverse interpret foreshortening angles accurately. Mind interprets 3-dimensional space from overlapping objects, shadows perspective. People born blind who regain sight must learn these concepts. Not instinct, learned. Foreshortening in comet observation, same principle. Tail extends in 3-dimensional space. Your view compresses it into 2 dimensions. Brain must account for angle to estimate true length. Most do not. See long tail in November. See short tail in July. Conclude tail grew. Miss the geometry. Technical details matter. JPL horizons, ephemerity service. Minor planet center provide accurate positions, rates magnitudes. Orbital elements at epoch July 25th, 2025, 00 UTC JD 2460882 2.5. Eccentricity 1.000016. Perihelion, distance 1.3618 astronomical units. Argument of perihelion 57.8 degrees. Longitude of ascending node 292.4 degrees. Inclination 174.2 degrees retrograde. Escape velocity trajectory never returns. Observations from Comet Observers Database. COBEs run by CRNI VR Observatory Slovenia. Community reports, visual estimates, images finder charts. Magnitude predictions, often inaccurate for comets due to outbursts, mantling fragmentation geometry. Observed magnitude more reliable than predicted. 3. Atlas observed magnitude around 12 to 14 through most observations. Faint. Required telescope's aperture at least 3 to 4.5 inches. Much fainter than Comet Lemon magnitude. 5.1 detectable. Naked eye dark skies. Much fainter than Comet Swan. About 120 times fainter than Lemon. 190 times fainter than Swan during Mars. Approach October 3rd. November, observations clear. Tail visible growing not from sudden mass loss, but from perspective improvement. Solar elongation increased as comet moved away from sun into morning sky. Rose above eastern horizon hours before dawn. moved through Virgo Leo during December. Brightness expected to dim below magnitude 12 as distance from Sun increased. Activity decreasing, sublimation slowing. But visible tail length might stay constant or even increase slightly as viewing geometry continues improving until Earth's orbit carries us past ideal broadside angle. Then foreshortening increases again as comet recedes and angle shifts back. Tail appears to grow, then shrink, not because tail changes, but because Earth moves. Your platform orbits Sun at 30 kilometers per second. Comet moving at different speed, different direction. Relative geometry constantly evolving. What you see today differs from what you saw yesterday, differs from what you will see tomorrow. Not because object morphed, because angles changed. Ion-tail disconnection events occur when magnetic field lines squeeze together along tail. Magnetic reconnection happens. Tail breaks off. Observed multiple times. Comet Inca, April 20th, 2007, ion tail completely severed, passing through coronal mass ejection seen by stereo spacecraft. Comet C2009, R1 McNaught, May 26th, 2010, disconnection event. 3. I-Atlas, no reported disconnection yet. Tail intact. Streaming. Comet Lemon. October 2nd, 2025. Disconnection event captured by Alan Gilmore's 60-minute time-lapse. Colossal section buffeted, stripped away by solar wind. Takahashi Epsilon 130 D Newtonian telescope. ZWO camera Sysmont, Virginia. Tail shredded. Reformed. Normal behavior for active comets and solar wind. 3. I-Atlas might experience similar events. Depends on solar wind conditions, coronal mass ejections, magnetic field strength. Not predictable. Monitored. Myth says comet tails always trail behind along orbit. Not exactly. Ion tail points away from Sun, regardless of motion direction. Dust tail curves slightly trailing, but still primarily anti-solar. Myth says all comets are dirty snowballs. Classic phrase captures ices and dust, but modern results show complex geology, organics, diverse compositions. 3. I-Atlas, carbon dioxide, rich low water, unusual but natural. Myth says brightness predictions are firm. They are not. Outbursts, mantling, fragmentation, geometry confound predictions. 3. I-Atlas predicted magnitude 11.5. Actual observations showed 12 to 14 with outbursts. Variability, normal. Myth says interstellar objects must behave differently. Not necessarily. 2. I-Borisov looked like solar system comet. 3. I-Atlas looks like active comet. Chemistry differs, composition varies, but physics same. Sublimation radiation pressure, solar wind gravity, universal laws. Myth says tail growing after conjunction means alien propulsion. No, means geometry changed, perspective shifted, foreshortening decreased. You rotated around the object. Object stayed same. You moved. Perspective illusion powerful. Milky Way looks like band because stars stack across galactic disk distance. Actually, spiral disk viewed edge on. Anti-tail looks like spike pointing towards Sun because dust stacks across orbital plane. Actually, dust sheet viewed edge on. Railroad tracks look like they converge because parallel lines foreshorten with distance. Actually stay parallel. Comet tail looks short in July, looks long in November because line of sight angle changed. Actually, same tail, different view. Brain struggles with three-dimensional interpretation from two-dimensional projection. Artists studied this for centuries. Renaissance linear perspective formalized it. Alberti, 1435-1436. Kilian Kubovi. Modern analysis. Foreshortening results from two effects. Visual angle shrinkage with distance, increase in optical slant with distance along ground. Combined compression, comets at third dimension. Motion through space, while observer also moves. Dynamic geometry, constantly shifting angles. Tail appears to pulse, grow shrink wave. Not pulsing, not waving. Rotating into and out of favorable viewing angles as comet and Earth trace their paths. Scientists continue observations. Hubble ultraviolet spectroscopy. November 2025, determining gas composition, sulfur to oxygen ratio. Monitor, comet outbound. JWST, next observations. December 2025, post-perihelion. Expected data, early 2026. JUICE, November 25th observation. Juno, March 16th, 2026. Jupiter flyby. Parker Solar Probe. Potential observations if geometry allows. Ground-based campaigns, coordinated through International Asteroid Warning Network. Observing window, November 27th through January 27th. Check-ins through early February. Community exercise, improving comet astrometry, reducing biases from fuzzy Comey. amateur astronomers contributing, plate-solving smart telescopes, aperture 3 to 4.5 inches imaging objects much fainter than visual observers see, data accumulating, understanding improving, no threat to Earth, closest approach. December 19th, 269 million kilometers, no impact risk. Hyperbolic escape trajectory. A one-time visitor came from interstellar space, passing through. Leaving will not return. Journey continues billions of years, may approach another star in distant future, may continue indefinitely through galaxy, unknown destination. Known origin somewhere in Milky Way, thick or thin disk, Sagittarius, direction near galactic center. Opposite solar apex, unique trajectory, unique composition, unique opportunity, comparison to previous interstellar objects instructive. 1I Oumuamua. October 2017, discovered pan-stars, Hawaii. Hyperbolic trajectory. Small, elongated, possibly cigar-shaped or pancake-shaped. No visible coma, no tail, non-gravitational acceleration detected. Outgassing hypothesized, despite no visible activity. Hydrogen ice proposed. Nitrogen iceberg proposed. Various explanations. Tumbling rotation, unusual shape, left solar system, data limited, short observation window. 2. Borisov. August 2019, discovered Gennady Borisov, amateur astronomer, Crimea. Clearly active comet, visible coma and tail. Carbon monoxide rich, dust to gas ratio similar to solar system comets. Nucleus fragmented approaching perihelion. Observations extensive. Resembled solar system comets closely. 3I Atlas, July 2025, third interstellar. Active comet. Carbon dioxide dominated, low water. High cyanide. Unusual polarization. Unusual trajectory alignment. Unusual mass and speed. Unusual timing arriving near multiple planets during solar conjunction. 12 anomalies documented. Lobe scale rank 4. Natural explanations available for all. Volatile rich ices. Sublimation. Solar heating. Rotation. Outgassing. Perspective effects. No confirmed artificial signatures. Radio signal explained by hydroxyl chemistry. Tail growth explained by viewing geometry. Jets explained by active surface regions. Non-gravitational acceleration explained by rocket effect from mass loss. Trajectory explained by ejection from parent star system billions years ago. Random walk through galaxy until encountering sun. Post-perihelion November images. Confirm comet intact, single body, not fragmented. Sunward anti-tail present. Ion tail visible lengthening. Coma bright. Activity ongoing. December, observations will show continued evolution. Tail may appear to keep growing as Earth viewing angle improves further. May reach maximum apparent length mid-December, then begin shrinking as geometry shifts past optimal broadside view. Physical sublimation will decrease as comet moves away from sun, heliocentric distance increasing, solar heating decreasing, activity dropping. But apparent tail length driven by two factors: physical size and viewing angle. Both matter. January observations will show dimmer comet, smaller coma, shorter tail as both physics and geometry work together. By February, magnitude will drop below most amateur equipment range. Professional observatories will track it. Hubble Webb, JUICE, Juno. Data accumulating slowly. Years of analysis ahead. Comparison to solar system comets. Comparison to other interstellar objects. Composition studies. Outgassing rates. Dust properties. Orbital refinement. Origin determination. The tail looks longer after conjunction because you moved. Earth orbited. Angle changed. Foreshortening decreased. What was compressed became extended. What pointed at you now points across you. The tail itself grew from increased sublimation near perihelion. That part is real. But the dramatic visual change, the thing people notice, the screenshots shared online that comes from geometry, not from sudden doubling of material. Same reason railroad tracks converge. Same reason buildings shrink with distance. Same reason the moon looks huge on horizon, small overhead. Perspective, viewing angle. Three-dimensional object projected onto two-dimensional perception. Brain interprets, often wrong, needs training, needs awareness. Comet tail million kilometers long, viewed head-on, looks like fuzzy blob. Same tail, viewed broadside, looks like spectacular streak. No change in comet, change in observer. You are the variable, your position, your angle, your line of sight. The comet does not care, keeps moving. Keeps sublimating, keeps streaming gas and dust into space. Your view changes, your perception shifts. The illusion grows. The truth stays simple. Physics and geometry, nothing more. In Chile, at Rio Hurtado, observatory code W68, where Atlas discovered 3. iAtlas on July 1st, 2025. Astronomers continue monitoring. Telescopes tracking faint, fuzzy objects moving through star fields. Data uploading to Minor Planet Center. Orbital elements refining. Predictions improving. Other observatories joining. Global network, professional and amateur, space-based and ground-based, coordinated effort, rare opportunity, third interstellar object ever detected, possibly oldest ever observed, time capsule from early universe, composition revealing conditions in different stellar system billions years ago, chemistry frozen preserved, traveled unaltered until solar heat released it, water content, carbon dioxide content, carbon monoxide, cyanide, nickel, dust, all clues, all data, all science, no aliens, no propulsion, no technology, just ice and rock and physics, just sublimation and radiation and gravity, just geometry and perspective and foreshortening. The tail looks longer because the angle changed. That is the answer. That is the fact. That is the truth. On November 11th, 2025 at 0431 UTC in Manciano, Italy, Gianluca Massi pointed his Moravian C 361000 EC mono CMOS camera through his Artec 250F 4.5 astrograph mounted on software bisque paramount toward the eastern horizon where 3i Atlas hung 12 degrees up, pale against dawn twilight and captured light that had left the comet's coma. Minutes earlier, traveled 269 million kilometers through vacuum-crossed Earth's atmosphere. Struck his sensor and became pixels in a file, and in that file he saw what everyone now sees, the ion tail stretching visibly across the frame, longer than July, longer than August, not because the comet exploded, not because engines fired, not because physics broke, but because Earth moved and the angle changed, and what was hidden became clear. And he wrote now that the comet is moving into morning sky. Its tail, which was behind the nucleus, as seen from Earth at perihelion, is more and more visible, and he was right, and that is all there is. And that is the whole story, geometry perspective, foreshortening the mathematics of angles, the physics of light, the simple, unavoidable fact that when you change position, you change view, and when you change view, you change perception. And when you change perception, the same object looks different, not because it changed, but because you did.